Have you ever looked up at the night sky, at that vast, silent sea of stars, and wondered, what does it sound like out there? We're often told space is a vacuum, and in a vacuum there's no sound. Well, that's only part of the story. Today we're going on an auditory journey into the cosmos to listen to the incredible, hidden music of the stars. Stick around, because what you're about to hear will change the way you see the universe forever. First, let's get the big question out of the way. If space is a vacuum, how can we hear anything? You're right, sound as we know it vibrations traveling through a medium like air or water and travel through the emptiness of space. But stars aren't silent. They're incredibly dynamic, chaotic, and energetic objects. They hum, they throb, they flare, and they quake. And all of this activity produces waves. Not just light waves, but other kinds of waves like plasma waves and magnetic field vibrations. Scientists have developed incredible ways to capture these vibrations and translate them into sounds our ears can understand. This process is called data sonification. It's like turning cosmic data into a cosmic symphony. So what does our own sun sound like? It's the star we know best, and thanks to missions like NASA's SOHO, we've been listening in for years. The sun is a churning ball of hot gas, with energy constantly moving from its core to its surface. This movement creates pressure waves, essentially sound waves, that bounce around inside it. By studying these waves, a field called helioseismology, scientists can learn about the sun's interior, much like how geologists use earthquake waves to study Earth's core. When these solar vibrations are converted to audible frequencies, they create a low resonant hum. It's a constant, deep, powerful thrumming, the heartbeat of our solar system. Imagine a gigantic gong, the size of 1,000,000 Earths, vibrating continuously for billions of years. That's our sun. It's a sound that's both humbling and incredibly reassuring, the steady rhythm that governs our lives. But our sun is just one star among billions. What about others? Well, every star sings its own unique song. The pitch and rhythm of a star's song depend on its size, age, and composition. For example, massive, hot young blue giants have a higher-pitched, more frantic sound. They live fast and die young, and their sound reflects that chaotic energy. Think of a rapid, intense drumming. On the other hand, older, cooler red giants, which have swelled up near the end of their lives, have a much deeper, slower, and more melancholic tone. Their vibrations are slower, creating a sound like a low, mournful cello. It's a cosmic ballad of a life long lived. By listening to these stellar songs, astronomers can determine a star's physical properties without even needing to see it clearly. The sound tells the story. This is a whole new field called astroseismology, the study of starquakes. Let's dive deeper into some specific examples. Take pulsars, for instance. These are the super dense, spinning remnants of massive stars that have exploded. As they spin, they emit beams of radio waves from their magnetic poles. If one of these beams happens to sweep across Earth, our radio telescopes pick it up as a regular pulse. When we convert these radio pulses into sound, we get an incredibly precise, rhythmic beat. Some pulsars spin hundreds of times per second, creating a sound like a high-frequency buzz or a cosmic metronome. Each pulsar has its own unique tempo, a steady beat that has been ticking away for millions of years. It's the most reliable clock in the universe. Listening to a pulsar is like listening to the ghost of a star, its rhythmic heartbeat echoing across the galaxy long after its fiery death. And then there are the real rock stars of the cosmos, black holes. Now, black holes themselves don't make sound, as nothing, not even light, can escape their gravitational pull. But the environment around them is one of the most violent and energetic places in the universe. As gas, dust, and even entire stars get pulled towards a black hole, they form a swirling, superheated disk called an accretion disk. The friction and intense gravitational forces in this disk generate massive amounts of energy, including powerful plasma waves and X-rays. In 2003, astronomers studying the Perseus galaxy cluster discovered something mind-blowing. They detected pressure waves rippling through the hot gas surrounding a supermassive black hole at the cluster's center. These were, for all intents and purposes, sound waves. The note they detected was a B-flat, but it was about 57 octaves below middle CA frequency, so low it would take 10 million years to complete one vibration. Scientists had to raise the pitch 57 octaves just for us to be able to hear it. The result is an eerie, deep, cosmic moan. It's the lowest note ever detected in the universe, the true bass line of the cosmos. Beyond individual objects, the universe itself is filled with a kind of background hum. This is the cosmic microwave background, or CMB. It's the leftover radiation from the Big Bang, the afterglow of creation. This radiation isn't perfectly uniform. It has tiny temperature fluctuations. When scientists sonify this data map of the early universe, they create a sound that is truly primordial. It's a wash of static, a hiss containing all the frequencies, like an untuned radio. But within that hiss, you can hear subtle fluctuations, the sonic imprints of the seeds that would eventually grow into galaxies, stars, and planets. Listening to the CMB is like listening to the universe when it was just a baby, a mere 380,000 years old. It's the oldest sound you will ever hear. So, what can we learn from all this cosmic music? It's not just a beautiful curiosity. Data sonification is becoming a powerful tool for scientific discovery. The human ear is incredibly good at picking out patterns, sometimes even better than our eyes or computer algorithms. By listening to data from space, astronomers can identify subtle patterns, anomalies, and rhythms that might have been missed in visual graphs or charts. It can help them classify stars, detect exoplanets, and understand the complex physics of black holes. It's a completely new way of exploring the universe, adding a rich auditory dimension to our understanding of the cosmos. It turns astronomers into cosmic DJs, mixing tracks that are literally out of this world. The next time you gaze at the night sky, remember that it isn't silent. It's filled with a symphony of unimaginable scale and beauty. From the deep hum of our sun to the rhythmic beat of pulsars, the mournful songs of dying giants, and the deep moan of a black hole, every object is playing its part in a grand cosmic orchestra. We just needed the right technology to tune in and listen. The universe has been singing since the dawn of time, and we are finally beginning to hear its song. Thank you so much for joining me on this auditory journey through space. I hope it's given you a new appreciation for the hidden wonders of our universe. If you found this fascinating, please hit that like button and consider subscribing to our channel for more deep dives into the mysteries of the cosmos. Let us know in the comments what celestial sound you'd love to hear next. Until next time, keep looking up and keep listening.